This video is going to demonstrate using vectors to solve for displacement. So the scenario given, a helicopter flies 12 kilometers north and 8 kilometers east. So let's draw a diagram. I've got my north is this way, so this is 12 kilometers. East is this way. This vector is 8 kilometers. And I'm going to draw a little helicopter here. A little tail, something like that. Okay, and we're simply going to use trigonometry to solve this problem. We're being asked to find displacement, so really what we're being asked is, what is the length of the hypotenuse for this right-angled triangle? What is the value of x? So when we're working with displacement, we're looking at a vector quantity, not a scalar. So we want to calculate magnitude, which is going to be the length of x. We're also going to want to find the size of this angle, which is going to give us the direction of the displacement. So I'm going to use Pythagoras' theorem here to solve for x, and then I will use the trig ratios to find the direction. So pretty simply, I'm trying to find the length of the hypotenuse, which is c squared. So I want 8 squared plus 12 squared is going to give me x squared. So I want the square root of 208, which is going to be 14 kilometers. That is the magnitude. This is 14 kilometers. And now I want to solve for the size of this angle. So if my angle is down here, and I know that it's that angle because of the direction that we're traveling, if the angle is down here, then this side that's 12 kilometers is adjacent. And this side of the triangle, which is 8 kilometers, is opposite. So I've got the size of the opposite and the adjacent angles. So when I have a look at my trig ratios, here we've got opposite and hypotenuse. Here we've got adjacent and hypotenuse, opposite and adjacent. So this is the trig ratio I'm going to want to use here. And part of the reason why, I just solved for the hypotenuse, so technically I could use the sine or the cos ratios, but if you make an error, if you've made a mistake in that first step, then that mistake is going to carry through into the second part of the problem. Whereas if I use my tan ratio, I know that it's at least that's going to be correct, just in case you have made an error somewhere earlier. So if I've got opposite and over adjacent, then I'm looking at tan. So tan angle is equal to opposite over adjacent, which is 8 over 12 kilometers. So the size of the angle is going to be the inverse tan, which is literally a button on your calculator. Don't stress if you don't know what that means, you can plug it into your calculator. So the inverse tan of 8 over 12 is the size of the angle, which is 33.6 degrees in a northwest direction, which we were told, a northeast direction, which we were told in the problem. Northeast. So our final answer, the displacement, is going to be 14 kilometers, 33.6 degrees northeast.